Dear all, hoping you are all fine. I really miss you very much. I miss very much your interactions. This is our second week lectures, financial economics lecture. And this chapter will be about risk and return and the capital asset pricing model. This chapter will be divided into several parts and we'll cover these parts during the next weeks. This week, inshallah, we will cover the first one, which is the first part 1. So here this week we will begin with part 1, which is risk and return of one asset. Our lecture this week will be about risk and return of only one asset, not portfolio. Introduction. To take any financial decision, you have to take into consideration 2 important things, which are risk and return. So as an investor, to make any investment, you have to take into consideration what is the risk related to your investment and what is the return. Consequently, the main objective of the investor is to maximize the return for his or her investment, taking into consideration the existence of risk. So your goal as an investor is to maximize the benefit, which is the return for your investment, but you have to take into consideration that most probably there will be a risk. General concepts. In this slide, we'll talk about risk and return. So what about risk? It's the variability of returns that are expected from investments. So it's how returns may differ from investment during specified period. For example, if you are a shareholder, you can expect that your dividend will differ during specified period. Maybe the first year you will take higher return, higher dividend. The second year you will take lower return, low dividend. Maybe the third year you will take nothing, 0 dividend. So risk is the variability of returns that are expected from investments. As your return as an investor will differ, this will involve risk. Also risk, it is the measurement of unexpected changes of investment returns, which is uncertainty. So risk, it is the measurement of unexpected changes of investment returns. And these unexpected changes of investment returns may be related to reasons, which is related to firms, or related to macroeconomic conditions. These unexpected changes of investment return may be due to reasons related to firms or reasons related to macroeconomic conditions. And this will be covered, inshallah, in this chapter. The higher the uncertainty of the investment return, the higher its risk. So, the investment will involve higher risk when this investment is characterized by higher uncertainty of the return, which is logic. Again, the investment will involve higher risk when this investment is characterized by higher uncertainty of the return. So risk is the variability of returns that are expected from investment. It is the measurement of unexpected changes of investment returns. The higher the uncertainty of the investment, the higher its risk. So what about return? It is the total gain or loss incurred by the investment during a specified period. So return, take care, it's gain or loss, positive or negative. It's not always positive, but it can be positive or it can be negative. Types of investors. We mentioned these types of investors in introduction chapter, but we'll go through again. We have 3 types of investors. Number 1, risk-averse, conservative investor. Number 2, risk-lever, aggressive investor. Number 3, risk-neutral investor. Number 1, risk-averse or conservative investor. Giving a choice between 2 assets with equal rates of return, an investor will select the asset with lower level of risk. So here, giving a choice between 2 assets with equal rates of return, an investor will select the asset with lower level of risk. 2 assets with equal rates of return, risk-averse investor will select the asset with lower level of risk. This is risk-averse investor. Number 2, risk-lever, aggressive investor. Giving a choice between 2 assets with equal rates of return, an investor will select the asset with higher level of risk. So here, giving a choice between 2 assets with equal rates of return, an investor will select the asset with higher level of risk. So although the 2 assets give equal rates of return, risk-lever investor will choose the asset with higher level of risk. Why is risk-lever? Number 3, risk neutral. Giving choice between two assets with equal rates of return, this investor is indifferent between them. So here you see 3 types of investor: risk averse, risk lever, and risk neutral. But portfolio theory will assume that investors are basically risk averse. Through our chapter, we will assume that we are talking about investors, the first type, risk averse investor. But before studying the measurement of risk, you have to remember the concept of variance. We will begin with defining the concept of variance. So to remind you, the variance is used as a measure of how far a set of numbers are spread out from each other, dispersion. It's one of several descriptors of probability distribution, describing how far the numbers lie from the mean, expected value. So again, the variance is used as a measure of how far a set of numbers are spread out from each other, and it describes how far the numbers lie from the mean. And now we will talk about how to calculate the risk and return of one asset. So we'll begin talking about how to calculate the risk and return of only one asset. Determining expected return. In this slide, we will get a rule to calculate the expected return. So what is the rule? The rule is R bar equal to summation from I equal 1 to n, Ri times Pi. Again, the rule R bar equals summation Ri Pi. What's R bar? R bar is the expected return for the asset. You have only one asset and you want to get the expected return for this asset. What is the expected return? It's R bar. Equal to summation Ri. Ri is the return for the i's possibility. Ri is the return for the i's possibility. For example, for any asset, you can expect different return with different probability. So you can expect that you will get 5% return with 0.2 probability. You can expect 6% return with probability equal to 0.5 and so on. So you have different return and each return with probability. What is the probability? It's Bi. So Bi is the probability of that return occurring. So the rule equal to summation Ri times Bi. And n, it is the total number of possibilities. It is the total number of possibilities. So n, it is the total number of possibilities. So you have R bar equals summation Ri Pi. R bar is the expected rate of return for the asset. Ri is the return for the i's possibility. Pi is the probability of that return, and n is the total number of possibilities. And we will apply this rule the next slide in a problem. How to determine the expected return? This is our problem, and we have to apply the previous rule, which is R bar equals summation Ri Pi. What is the information given in this problem? You see a table, you have stock, which is one asset, BW. So we have only one asset, stock BW. The first column is Ri, the second column is Pi. So the given information, you have one stock, which is BW, and you have Ri, the returns for i's possibility, and you have got the probability. So this is the information given in this problem. So the third column, as a student, you have to calculate it. You have to multiply Ri times Pi You have to multiply RI and PI to get the result. So in the first column, you have RI, which is different returns. For the first return, you see negative 0.15, which means as an investor, yes, you have a loss. As I've said, return can be loss or gain, can be negative or positive. Then this return is negative 0.15 with probability 0.1. Then as an investor, you expect that you will get loss equal to negative 15% with probability 0.1. The second row in the first column, negative 0.03. As an investor, you will get loss equal to negative 3, negative 0.03. And this loss with probability, yes, 0.2 from the second column, which is PI. So as an investor, you expect that you will have a loss equal to negative 3 with probability 0.2. Then the third return, you expect you will get 9%, which is positive, which is gain, 9% return with probability in the column of PI 0.4. The fourth return, you expect you will get 21% return or 0.21 return with probability 0.2. And the last one, you expect you will get 0.33 return or 33% return with probability 0.1. Please take care that the second column, which is the column of probability, the summation of it must be equal to 1. The summation of probability must be equal to 1. The third column, you have to calculate it yourself. Please take care, you have to calculate it by yourself. You have to multiply RI with PI. So multiplying the first row, negative 0.15 times 0.1 will give you negative 0.015. Again, multiplying negative 0.15 times 0.1 will give you negative 0.015. The second row, you have to multiply negative 0.03 times 0.2 and you will get negative 0.006. The third row, you have to multiply 0.09 times 0.40 and you will get 0.036. The fourth row, you have to multiply 0.21 times 0.20 and you will get 0.042. And the last one, you have to multiply 0.33 times 0.1 and you will get 0.033. So again, the third column, you have to calculate it yourself. You have to multiply RI times PI. Then we apply the rule. What is the rule? R bar equals summation RI times PI. Then you have to sum each row in the third column. You have to add negative 0.015 with negative 0.006 with 0.036 with 0.042 with 0.033. You have to sum these numbers in the third column and the answer will be 0.09. So you can conclude that the expected return R bar for stock BW will be equal to 0.09, which is equal to 9%. So from the given information, different return with different probability, you will get the expected return. You multiply RI with PI to get RI, PI, and then you sum the rows in this column to get at the end the expected return, which is R bar, which is equal to 9%. So given this information, the expected return for this stock will be 9%. Defining risk. In the previous slides, we defined risk as it is the variability of returns that are expected from investment. But in this slide, we will add another definition, which is the variability of returns from those that are expected. So here we compare between what investor expects as a return and what he actually takes as a return. So the difference between what the investor expects and what the investor actually takes. So again, in this slide, we define risk as it is the variability of returns from those that are expected, the variability of actual returns from those that are expected. So it is the difference between answering the coming two questions. The first one, what rate of return do you expect on your investment this year? So this is the expectation of the investor. What rate of return do you expect on your investment this year? As an investor, you will expect certain return. But the other question, what rate will you actually earn? What is the actual return that you will take from this investment? So here the difference between these two questions will be the risk. The difference between answering these two questions will be the risk. So again, the risk is the variability of returns from those that are expected, which is the difference between the actual return and the expected one. Total risk. Total risk equal to systematic risk plus unsystematic risk. So in this slide, we will talk about two types of risk, systematic risk and unsystematic risk. So the first one, which is systematic risk. It's non-diversified or market risk caused by macroeconomic variables such as volatility of money supply or interest rate. This risk cannot be avoided by diversification. So I will explain it by dividing it into two parts, definition and its relation with risk. So it's non-diversified or market risk caused by macroeconomic variables such as volatility of money supply or interest rate. So this risk is related to market conditions such as unexpected changes in interest rate, inflation rate, exchange rate, taxes, and so on. So again, this risk is related to market conditions as unexpected changes in interest rate, exchange rate, inflation, taxes, and so on. And also it's related to natural disaster such as earthquakes, volcanoes, and so on. So this risk is related to market conditions or it's related to natural disaster. So this risk is not related to certain firm, but it is related to the market condition. So you can expect as an investor that this risk will affect all types of assets. It will affect all firms, not certain firm. This risk, this unexpected change in any macroeconomic variable will affect all types of assets, not only one type, will affect all firms, not only certain firm. So the second part, this risk cannot be avoided by diversification. If you are an investor and you bought several assets, several types of assets from several firms, you cannot avoid this risk. Why? Because as I said, this risk is related to the market conditions. So it will affect all types of assets. So even if you or your portfolio is diversified by several assets, you will not avoid this risk. Okay, the second one is unsystematic risk. It is a unique risk caused by the business conditions of some firms. This risk could be reduced by diversification. So again, I will divide it into two parts, the definition and its relation with risk. So unsystematic risk, it is a unique risk caused by business conditions of some firms. So unsystematic risk, from this definition, is related to certain firm, certain conditions in firm. For example, workers strike, إضراب عمال. For example, the extinction of one of the means of production, انقراض أحد وسائل الإنتاج في الشركة دي, and so on. So it's related to certain firm, not related to the market. So you can expect that this risk could be reduced by diversification. So as an investor, you will diversify your portfolio. You will buy certain assets from this firm and another asset from another firm. You will buy different assets and so on. So this risk could be reduced by diversification. You will not buy all your assets from one firm, but you will diversify, and so you can reduce this risk. So again, systematic risk is related to the market conditions, and this risk cannot be avoided by diversification. Unsystematic risk is related to the firm, and you can reduce this risk by diversification. Again, related to risk, we will talk about how to measure risk. We'll use beta coefficient and standard deviation. Beta coefficient is used to measure the systematic risk, and I will explain it inshallah next slides. And standard deviation is used to measure the total risk, which is systematic and non-systematic. So again, beta coefficient is used to measure the systematic risk, and I will cover it inshallah next lectures. And standard deviation is used to measure the total risk, systematic and non-systematic, and we'll cover it now inshallah. In this slide, we will talk about two rules for measuring total risk between brackets, systematic and non-systematic. So this slide, we will talk about measuring total risk, systematic and non-systematic risk. We have two rules, one for standard deviation and the other one for coefficient of variation. So we can measure total risk for an asset by using standard deviation and by using coefficient of variation. The first one, standard deviation, which is equal to square root summation Ri minus R bar, which is expected return, all power 2 times Pi probability. So again, standard deviation equal to square root summation Ri minus R bar all square times probability. And we will apply it now, inshallah. Coefficient of variation equal to sigma or standard deviation divided by R bar expected return. Again, coefficient of variation equal to standard deviation divided by R bar expected return. And we will apply these rules in the next slide, inshallah. Determining standard deviation, which is a measure of total risk, systematic and non-systematic. So what is the rule to calculate total risk, systematic and non-systematic? The rule will be sigma equal square root summation I from 1 to n Ri minus R bar all square times Pi. Again, the rule equal square root summation from I equal 1 to n Ri minus R bar all square times Pi. Ri is the returns for i's possibility, R bar expected return, and Pi the probability. So standard deviation, sigma, is a statistical measure of the probability of a distribution around its mean. and it is the square root of variance. And we talked about the definition of variance in the previous slides. So again, you can measure total risk, systematic and non-systematic, by applying this rule, which is the standard deviation rule. And we'll apply it inshallah next slide. How to determine the expected return and standard deviation. So in this slide, we will apply the previous rule, which is the standard deviation rule, to calculate total risk, systematic and unsystematic risk. So again, this slide will be an application for our rule of standard deviation. What is the information given? The information given is that you have only one asset, which is stock BW, and you have given RI, which is the return for I's possibility, and BI, which is the probability. So this is the information given to you to calculate the standard deviation. The first column, which refers to Ri, the return for I's possibility, will give you different values for returns. The first one is negative 0.15, negative 0.03, negative 0.09, 0.21, and 0.33. And the second column, the probability 0.1, 0.2, 0.4, 0.2, and 0.1, and take care that the summation must be equal to 1. The summation of probability must be equal to 1. So as I have said before, in calculating the expected return, the first row of Ri will tell you that the return is negative 15% with probability 0.1. The second row will tell you that the return may be negative 3% with probability 0.2, and so on. As I said before, in our example that's related to expected return. So given this information, which is you have one asset and Ri and BI, you have to calculate the standard deviation. So several steps will be done. The first one, you will have to get the third column. You will have to calculate the third column. What is the third column? It is the multiplication of Ri and BI. Why? Because you have to apply the rule of standard deviation. What is the rule? It is the summation Ri minus R bar all square times BI, then you will have to get the square root. So by calculating the third column, you will get, yes, you will get R bar. So third column, you will apply or you will calculate it to get R bar, the expected return. To get the expected return, you have to apply the rule of expected return. Then you have to multiply Ri, the first column, with BI, the second column, to get R bar. So you'll have to multiply the first row and the first row in the first column and in the second column. So we have to multiply negative 0.15 times 0.1, and you will get negative 0.015. Then you multiply the second row in the first column, and in the second column you will multiply negative 0.03 times 0.2, and you will get negative 0.006. Then you multiply the third row in the first and second column, 0.09 times 0.4 to get 0.036. Then you multiply 0.21 times 0.2 to get 0.042, and last you will multiply 0.33 times 0.1 to get 0.033. Then you have to add all the rows in the third column to get the expected return. Again, you have to add all the rows in the third column to get the expected return. After adding, you get 0.09, so the expected return, as in the previous example of expected return, will be equal to 9% or 0.09. But here, we will take it as 0.09 to calculate the fourth column. What is the fourth column? It is Ri minus R bar all square times Pi, which is the probability. Again, the fourth column, Ri minus R bar all square times Pi. So here you have to use the first column and the result of summation of third column, and then you have to square. So you will subtract the summation, which is 0.09 of the third column, from each return in the first column. Again, you will have to subtract 0.09, which is the result of summation of the third column, from each number, each return in the first column. Then you will have to square, and then you will have to multiply times Pi each time. So the first row in the fourth column, you will have to subtract 0.09 from negative 0.15. So it will be the first row in the fourth column will be negative 0.15 minus 0.09 all square times 0.1, which is the first row in the second column. Again, the first row in the fourth column, the last column, will be equal to Ri, which is negative 0.15, the first row in the first column, minus 0.09, which is the result of the third column, all square times 0.1, which is the first row in the second column, and you will get 0.00576. You will apply this on each row in the fourth column. So the second row, you will have to subtract and then multiply. So you will have to apply the rule negative 0.03, which is the second row in the first column, minus 0.09 all square times 0.2. Again, the second row in the last column will be equal negative 0.03 minus 0.09 all square times 0.2. You will get 0.00288. The third row in the fourth column will be equal 0.09 Ri, the third row in the Ri column, minus 0.09 all square times 0.4. So it will be equal to 0. The fourth one will be 0.21 minus 0.09 all square times 0.2. The result will be 0.00288. The last one, 0.33 minus 0.09 all square times 0.1, and the result 0.00576. So again, you will have to add the fourth column. You have to add all the numbers in the fourth column, and you will get 0.01728. So we'll have to add 0.00576 plus 0.00288 plus 0 plus 0.00288 plus 0.00576. You will get 0.1728. So again, the information given is you have one stock, Ri and Pi, and you have to find the standard deviation which is the total risk to measure the total risk, systematic and unsystematic. You will have to get the third column by multiplying the first column and the second column, and you have to add the numbers in the third column to get the expected return. Then the fourth column you have to apply the rule, which is Ri minus R bar square times Bi. Then you have to subtract the expected return you have got in the third column from each number, which is each return in the first column, then squaring, then multiplying by each number in the second column, which is Bi. Then you will add all the numbers in the fourth column, and then the last step will be in the next slide. Again, the last step will be applied in this slide. The last step of the previous problem will be applied in this slide. What is the last step? You will have to get the square root of the end result of the fourth column. You will have to get the square root of the summation of R minus R bar all square times Bi, which is the end result of the fourth column. So we'll have to get square root of 0.01728. Again, the standard deviation or sigma will be equal to square root 0.01728, which is equal to 0.1315 or 13.15%. So standard deviation or sigma will be equal to 13.15%. What does this mean? It means that the variability of returns from those that are expected is equal to 13.15%. Again, what does this mean? It means that the variability of returns from those that are expected is equal to 13.15%, and this is based upon the definition of risk. So again, this means that the variability of returns from those that are expected is equal to 13.15%. So here we can conclude that the higher the standard deviation, the higher the return variation, which means that when standard deviation is high, the variability of returns from those that are expected will be high, and this will lead to higher risk of investing in the asset. So again, the higher the standard deviation, the higher the return variation, the higher the variability of returns from those that are expected, the higher the risk of investing in the asset. For example, if you have two assets, asset A and asset B, and the standard deviation of asset A is 15 and the standard deviation of asset B equal to 25, then you can expect that the asset B with higher standard deviation will have higher return variation and will involve higher risk because its standard deviation is high. So the higher the standard deviation, the higher the return variation, and the higher the risk. So asset B will involve higher risk in case you invest in it. The second measure of total risk is coefficient of variation. Sometimes using standard deviation gives misleading results to compare the risks associated with investment. Coefficient of variation shows the risk per unit of return, and it provides a more meaningful basis for comparison when the expected returns on two alternatives are not the same, as it takes into consideration the expected returns of the two alternatives. I will explain this in details the next slide, so don't worry. What is the rule of coefficient of variation? Coefficient of variation equal sigma standard deviation divided by R bar expected return. So again, coefficient of variation equal standard deviation divided by expected return. And I'll explain this in details next slide, inshallah. The investment with lower coefficient of variation, lower risk, will be more attractive. So the investment with lower number of coefficient of variation will be more attractive. And of course, this is under the assumption that the investor is risk averse. This is under the assumption that the investor is risk averse. So here our example. If you have two assets, asset 1 and asset 2, and you have given certain information about the expected return of each asset and standard deviation of each asset. So the expected return of the first asset is 0.24 and the expected return for the second asset is 0.08. Which is higher? Yes, the expected return of asset 1 is higher, which is equal to 0.24. And standard deviation of asset 1 equal to 0.08, while standard deviation of asset 2 equal to 0.06, which is higher. It is the standard deviation of asset 1. So you can calculate from this given information the coefficient of variation. You have to apply the rule. By applying the rule, you have to divide standard deviation by expected return. The rule equals sigma divided by r bar. So we have to divide 0.08 divided 0.24 for asset 1. You have to divide again 0.08 divided by 0.24 so that you can get coefficient of variation which is equal to 0.33. So the coefficient variation of asset 1 you can get by dividing standard deviation by expected return by dividing 0.08 divided by 0.24. And the same for asset 2. You have to divide standard deviation, which is 0.06, divided by expected return, which is 0.08, to get coefficient of variation, which is equal to 0.75. Again, you divide 0.06 by 0.08 to get coefficient of variation 0.75. Okay, let's interpret our result. What is coefficient of variation? Coefficient of variation will show the risk per unit of return. So, by comparing coefficient of variation of asset 1 with asset 2, you can conclude that coefficient of variation of asset 1 is lower than asset 2. Why? Because coefficient of variation of asset 1 is 0.33 as compared to that of asset 2, which is 0.75. So coefficient of variation of asset 1 is lower. So the risk per unit of return, of expected return, is lower in asset 1 as compared to the risk per unit of expected return for asset 2. But if we explain the previous slide, which tells you that the coefficient of variation shows risk per unit of return, and it provides a more meaningful basis for comparison when the expected returns on two alternatives are not the same, as it takes into consideration the expected returns of the two alternatives. What does this mean? It means that standard deviation can give you misleading results. Why? And it's shown in this example. It can give you misleading results when you are comparing between different assets with different expected return. So, standard deviation can give you misleading results when you are comparing between different assets with different expected return. So here, if you are talking about standard deviation, you can see that standard deviation for asset 1 is greater than or is higher than standard deviation for asset 2. Standard deviation for asset 1 is 8%, while that for asset 2 is 6%. So standard deviation for asset 1 is higher than that of asset 2. This can give you misleading results. Why? Because you can conclude that asset 1 has higher risk as compared to asset 2. So standard deviation can give you misleading results. Why? Because according to interpretation of standard deviation, you will conclude that standard deviation is higher in asset 1 as compared for asset 2, so asset 1 will involve higher risk when compared to asset 2. But this will give you misleading results. Why? Because the expected return for asset 1 is much higher than expected return for asset 2. So if you divide the standard deviation by expected return, which is the coefficient of variation, you will find the end result lower risk per unit of expected return. So you have to better use coefficient of variation when comparing between different assets with different expected return. Why again? Because standard deviation will give you misleading results. When you compare the two assets based on standard deviation, you will conclude that asset 1 has higher risk than asset 2. Because standard deviation, which is 8% for asset 1, is higher than standard deviation for asset 2, which is 6%. But actually, this is a misleading result. Why? Because the expected return for asset 1 is higher, which is 0.24, 24%, while that of asset 2 is 0.08, which is lower. So if you divide the standard deviation by the expected return for each one, you will get the opposite result. How? As you see that the coefficient of variation of asset 1 is 0.33 and the coefficient of variation of asset 2 is 0.75, which is the opposite of the standard deviation. For asset 1, you have got lower risk per return, while that for asset 2, you have got higher risk per return. While standard deviation, which is the risk, without dividing by expected return, is higher for asset 1. So, by using standard deviation, you are concluding that risk for asset 1 is higher than risk for asset 2. But this is misleading result, because if you divide the standard deviation by expected return, you will get the opposite result, which is lower risk per return for asset 1 as compared to that for asset 2. So again, coefficient of variation that shows risk per unit of return, we provide more meaningful basis for comparison when the expected return on two alternatives or two assets are not the same. Why? Because it takes into consideration the expected returns of the two alternatives by dividing the standard deviation by these expected returns. And of course, the lower investment or the lower coefficient of variation related to the investment, the more attractive, as you will have lower risk per return. This is our last slide. And you can see that there is a positive relationship between return and risk when risk is measured by standard deviation. So again, there is a positive relationship between return and risk when risk is measured by standard deviation. So we can expect that high return will be associated with higher risk when risk is measured by standard deviation. And this can be shown in our previous slide, our previous example, when you have asset 1 and asset 2. Asset 1, you can see that you have higher expected return as compared to asset 2 and higher standard deviation as compared to asset 2. So asset 1 has higher expected return and higher standard deviation, and asset 2 has lower expected return and lower standard deviation as compared to asset 1. But asset 1 has higher expected return but lower coefficient of variation as compared to asset 2. So asset 1 has higher expected return but lower risk when measured by coefficient of variation. So there is no positive relationship in this case. Also, asset 2 has lower expected return but higher coefficient of variation, higher risk when measured by coefficient of variation. So again, there is no positive relationship in this case. So there is positive relationship between return and risk when risk is measured by standard deviation, and this can be shown in our previous slide or in our previous example. Okay, thank you. This is the end of our second week lectures, which is about risk and return. I hope everything is clear and I hope you understand well. And again, I miss you all and I hope I can see you as soon as possible. Bye bye.